Hi, today we're going to solve system of equations using the Cramer's rule, no? And that is part of the determinants, no? So we have these equations here: 5x plus 4y plus 3z is equal to 1, and 2x minus y minus z is equal to 7, and the third one is 3x plus y is equal to 6. So we're going to solve for the value of these variables, the three variables here. First, we are going to find the determinants, or we're going to use the determinants of the coefficient of matrix. No? So all the coefficients of the variables here, we'll put it as our matrix. No? So then we're going to apply the Cramer's rule and see if we can continue using Cramer's rule in solving these three equations here. So, to get the determinant of the coefficient matrix, you have here D is equal to, just copy all the variables of the coefficient of the variables, which are 5, 4, 3, and 2, negative 1, and 1. No? 5, 4, 3, 2, negative 1, and 1. And 3 plus y, no? And we're going to supply the missing coefficient of the variable z as 0, no? And then to solve for this matrix here, we're just going to repeat the first and second column of the matrix, no? So 5, 2, 3, and 4, negative 1, and 1. And then, to solve this one, no, we multiply, get the products of the three multiply all the three coefficients here, no? So 5 times negative 1 times 0 is equal to 0. 4 times negative 1 and 3 is negative 2, negative 12. 3 times 2 times 1 is 6. And all the slanted coefficients as negative, no? Beginning with 3 times negative 1 times 3 is negative 9. So you subtract, no? All of these going upward, no? So minus 1 minus 1, 1 times negative 1 plus 5. So that is negative, negative 5. And 0, 2, and 4, which is 0. So we combine all these products here. Negative 12 plus 15 is 3. Plus negative 5 is 8. No? So the D here for our coefficient matrix is 8. For the denominator, the denominator of the solution of x. So dx is equal to 1, 7. We change, no? Value of the coefficient of x as 176, no? Of the constants here, no? So this 5 to x will be replaced by 176, and also copy the coefficients of the y. So 4, negative y, and y. So 4, negative 1, and 1. And 3, negative 1, 3, negative 1 is 0. No? We supply the coefficient at 0. And then we just copy the first column, 176 and negative 1, 4, negative 1, and 1. Then similarly, we get all the products, positive as it is, no? And negative on the upward. No? So 1 times negative 1 and 0 is equal to 0. 4, negative 1 and 6 is equal to negative 24. 3, 7, 1. 3, 7, 1 is 21. So, minus, no? 6 times negative 1 and 3 is negative 18. And 1, 1, 1, 1, negative 1 and 1. So, negative 1 times negative 1. Negative times negative 1. So this one is 0, 7, 4, which is 0. We combine all these terms here. So negative 24 and 21 is negative 3. Plus 18 is 15. Plus 1 is 16. So we have here dx is equal to 16. For dy, we replace the coefficient of y by the constant term 176. No? And then do also the downward and upward operation. So for dy, we have here 5 times 7 0 is equal to 0. 1, negative 1, and 3 is negative 3. 3, 2, and 6 is 36. So 3 times 7 and 3. So 9 times 7 is negative 63. No? So the upward trend is negative. Minus, again, 6 times negative 1 and 5 is negative 30. And lastly, 0 minus 0, 2 and 1, 0. We combine all these terms here, all these products. So we have here negative 3 plus 36 is positive 33. Minus 63 is negative 30 plus 30 is 0. So dy here is 0. For dz, we replace the coefficient of z, which is 3, negative 1 and 0 by 176. So we have here 5, 4, 1, 2, 1, 2, negative 1 and 7, 3, 1, 6. So this one is our new z, no, value of z. And then we just copy the first and second column and then do the operation, the Cramer's rule. So 5, negative 1 and 6 is negative 30. 4, 7 and 3 is positive 84. 1, 2, 1 is 2. Minus 3, negative 1 and 1 is negative 3. So 1 times 7 and 5 is minus 35. Minus 6, 2 and 6, 2, 4, which is negative 48. Then we combine again. So this one is 54, plus 2 is 56, 57. So this one is 83 minus 57, which is negative 83 plus 57 is negative 24. So we now have the value. We now have the determinant of the coefficient of matrix X to be D is equal to 8. No? And also determinant of the numerator in the solution of X as dx is equal to 16. And also the determinant of the numerator in the solution of y, dy is equal to 24. And the determinant of the numerator in the solution of dc is equal to negative 24. To find the value of x, dx over d is equal to 16 over 8, this is 2. And y is dy over d. So since we have found the value of y to be 0, so y is equal to 0. And z is equal to dz over d is equal to negative 24 over 8. So that is equal to 3. So our value now is, for x is 2, 0, and negative 3. You should always remember that d should not be equal to 0, since all these values here will become undefined. So to check our work, we just substitute all these values of our three variables here, 2, 0, and negative 3, to our original equation. So we have these original equations here, 5x plus this one here. No? So since 5, since x is equal to 2, 5 times 2 is 10, and y is equal to 0, so this is 0. 3 times the value of z, which is negative 3, so 10 minus 9 is equal to 1. So for our second equation here, x is equal to 2, so this is 4. Z is equal to negative 3, so minus 3 is equal to 7, so this is correct. So 3 the value of x is equal to 2. So that is 6. And the value of y is equal to 0. So 6 plus 0 is equal to 6. So our answers are all correct. No? So that's it. No? That's how we're going to solve the solution. We're going to get a solution for the system of equations involving three variables using the Cramer's rule. So thank you for watching again. And please don't forget to subscribe to my YouTube channel by Wilfred Tan. And click that notification bell. No? So thank you and see you again later.